Welcome to the second Spark ML lab. So in the first lab, you would have already gotten hands-on with how do you build your model, right? So in the second lab, we'll go a little deeper into supervised learning, looking into building your pipeline typically for a text-based data, right? So in this data set, in this lab, we are going to use a SMS data set. So we'll take a look into pipelines, and then we'll look into a very important part of machine learning modeling, which is your model tuning, because you are not going to do just one model. You are going to always run multiple models, and then especially on models which have multiple parameters, right? So we are going to take a deeper look into model tuning. So let's get started.
All right. Welcome to the second lab, Spark MLlib lab, where we are going to explore pipelines and model tuning, right, using cross-validator. So we'll create a model using Spark pipeline and cross-validator library. So validator is similar to sklearn with search CV, right? So if you have multiple parameters to be tuned in a particular model, like your random forest classifier or your KNN, where K is a hyperparameter, right? So in this classification model, we will be using the SMS spam collection. So the data set has been provided to you. All right. So if you sort of open up the data set, you will see that it is not comma separated. So that's why it doesn't have a .csv in it, but you should still be able to add it on um, to your Databricks table as a table. Right, so these are essentially multiple. So this is actually a Singapore-based data set from the UCI repository. Right, so it's being classified as ham is not spam, and spam is all these spam junky messages that you get. Okay, so let's import a bunch of, so this is a classification. So we are importing a lot of these feature libraries like indexer, tokenizer, stopwords, a lot more this time, right? And then we are doing logistic regression, then multi-class classification evaluator, right? And cross validator and parent builder. Okay, so now so first we will start off by reading. So in this, we are specifying, because it's not comma, it's tab. So we are specifying the delimiter, right? And then we see that, hey, it has read two string columns, underscore C0 and underscore C1, column 0 and column 1. So we are just seeing the data as well. Okay, so now, so we are going to create this multiple steps that go with it, right? So the first step is converting your C naught, which is your Y variable, the target variable, into 0 and 1, right? So that's what the string indexer is going to do. Input variable is underscore C0 and the output variable is label. So the label is the default column it takes as the target variable, Spark models, right? So in the earlier example, we had given a fancy name, right? So if you are giving a fancy name, then you will have to specify it when you are creating the model object. Okay. So then let's go on to create your NLP steps, right? So now your target variable is done. So it's not done really. It is just that you have created an object. We haven't done the transformation. Okay. Just keep that in mind. Okay, so we are going to put all of these transformations together in a pipeline. So that's why we are not really doing the fit and the transform immediately. So then you have your, so a typical way how you deal with a classification problem is you can tokenize the text, right? And then do your count vectorizer. So before you do count vectorizer, you may want to remove the stop word. So you do your tokenizer, which splits your SMS messages into tokens. Then do your stop word remover, which removes all stop words from your token. And then create a count vectorizer, which is your document term matrix, right? So we are going to create an object for all of it. And it's very important to specify your input and output columns correctly here, because you're going to put them together in a series of stages in a pipeline object. Okay, so first we are doing tokenizer. So tokenizer takes C1 underscore C1 and creates an output column tokens. Then we are creating a stop word remover which takes tokens or tokenizes output column and creates tokens without stop words. So in this, of course, stop word remover, if you look at it, so this is going to use the standard set of stop word remover. But if you want to make it case sensitive, etc., you can specify all of these other parameters, just like you would in a sklearn. So if you want to so this is a standard set of English stop word removers it will do. Then we do your count vectorizer, which is going to take the output of your stop word remover and create your count vector at C vector. So after that, what do you do? After you do your count vectorizer, so count vectorizer is essentially your one-hot encoded vector, right? 0 and 1 on the dictionary matrix. Where whichever words are there, all of that will become 1. Otherwise, it's going to become 0. So you're taking that vectorizer output and creating your features vector, right? Features column, which is what is your predictor, whatever you are going to use as predictor. So we are creating an assembler, your vector assemblers, you're taking the vectorize output because this is a vector. So we are putting that into a list and we are going to create that as a features. Okay, so then we go ahead to do your regular machine learning. So do your train test split on your SMS data frame. So creating logistic regression. So if you remember in the last lab, when we specified logistic regression, we specified what was the label column, right? And we also specified what was the feature column. By default, the feature column is called features. So we already have the features column. We already have the label column. As in, we have all the transformation required. We have not done the pipeline yet. Okay, so that's what we are going to do. So there are. So if you remember in the last slide we saw, there's a bunch of operations that we want to do together, right? So we're creating all of these steps so that we can neatly put them into a pipeline. Okay, so now comes your pipeline. So now you are ready to start your pipeline itself, right? So in your pipeline, so it behaves exactly like your Spark models. So you can do a fit, right? And then you can do a transform to predict for your test data. Okay, so what you do, you create an object of pipeline. So very quickly, I want to point out where is your pipeline, right? So it is under PySpark.ml, you have pipeline, okay? So because it is one of your, so you can create a pipeline of any number of steps. So you can create your user-defined functions to do your transformation of your data as well, right? So you specify the stages and it's very important the order in which you specify it, right? So you're doing the indexer, tokenizer, stop word remover, vectorizer, assembler, and then logreg. Okay. So of course here the indexer can go either way. So you can do indexer anywhere because indexer is just doing the indexing on your target variable, right? So that order doesn't matter, but this order matters a lot, right? Because this should be in exactly the same order. You create your pipeline and then you specify because we are going to now run it through a grid search algorithm. Okay, so what we are going to do is we are going to pick so if you have multiple parameters, so we want to make sure that we pick the best model, right? So we are first creating the evaluation metric. So we want to pick the best model with respect to accuracy, right? So whichever has the best accuracy. Okay, so now we are ready, right? Because there are multiple things that you can tune because you have put a set of transformations into your pipeline, right? So here, what we are doing is we are just creating a very simple sort of grid search. We are not looking at the parameter of the model, logistic regression itself. So logistic regression, you can tune your parameter, which is your C parameter, right? Which is your uh, how much of yeah, the exact term is slipping my mind. But here we are looking to do your parameterization of your vectorizer vocab size, right? So we want to try for 3,000 and 4,000. These are the two. So else it's going to create for the set of all vocabulary that is there. And then we are also going to create a binary. So do you want to do count vectorizer where it's counting the number of words, or do you want to do only a binary vectorizer, right? So true is it's just going, as far as the word is present, it's going to give one, whereas false is every time the word occurs, it's going to create count the number of words. So we are creating the param builder. So now we are ready to do your cross validator. Okay, so this is the part. So now we are ready to do. So the cross validation will take the model, right, which is essentially your pipeline, because we have created this huge pipeline, right? Because every step will have a effect on your classification model. How many vocabulary size, whether it's binary, all of these are features, right? So everything will have an impact on the model. So we're creating a pipeline model, and then we are specifying the param grid of all the parameters we want to vary. And finally, on which metric do you want to create your validation, right? So once you create the object, so this is the part which is going to take all the time under the sun, right? So you are now creating this model fitting. So I'm just going to run it and then talk about it. Okay. So what is happening here? So your training data, so you did your train test split. So your training data is run through these each step. So you have your 300, 3000 vocab size, binary true, one such model. You have 3000 binary false, one such model. Then you have 4000 binary true, one such model. 4000 binary true, one such model. So how are we going to evaluate it, right? So that is where your cross validation comes into picture. Cross validation, it is going to do your k-fold cross validation. So if you look at it, the number of folds it's going to do by default is 3. Okay, so it's already creating 4 models. Okay, so each of those 4 models it's going to run 3 times, right? So it's essentially fitting 12 models, right? And then testing it on the fold that so every time it's testing on the fold that it has not used for creating the model, right? So you understand what's happening. So it's essentially doing, so if you look at it, the kind of spark job it creates, right? There are multiple steps to it. You can go ahead and view one of it. Just let me probably show you. Hopefully this comes up, right? So this is where you can actually see the aspect of your logical plan and your physical plan that comes together, right? Because your data set is distributed, and on top you are going to do your cross validation. So much of data movement actually has to happen in order to create this, right? So that is why you should have an optimized logical plan, and then your physical plan comes in, and then your DAG is created. So let's wait. So this is very similar to your grid search cross validation technique, right? So you must have read about cross validation when you did your machine learning model. So it is a way of if you just do train test split, you're just doing train and looking at in your test data. Whereas when you do cross validation, you're splitting your training data into multiple folds and then building multiple models and picking the one which has the average cross validation. So in this case, we want to pick a model which has the highest accuracy. So I think this has finished running. So once this has finished running, right? So you can actually go ahead and do your transformation with your test. So here you can also see, okay, so I'm going to see which is the best model. Let's see, best model get para. Okay. So I just need to look at. So the best model is an object itself. So I'm just trying to find which is the function which will get us the. Okay. So I'm just going to look at param. Let's see what happens. So that doesn't come. So I wanted to see which was the winning model, right? So I think I forgot which was the exact. So I'll try one more and then probably let you take a look at. Okay. Okay. So this is the best model itself, right? So you can see the pipeline model. You can go into the documentation to see which one will give you the parameter. So the best model is what is being used for transformation. So on your test data, you get your predictions. Then you are evaluating the predictions, right? So what is your evaluation metrics? Accuracy. So in this case, accuracy is 94.95 on your test data for the best metric, right? So go ahead and so I will give you links to these documentation so you can play around with it, try out different what happens if you change the stages, etc., right? And if you create a let's say instead of a logistic regression, you're creating a random forest classifier, right? In that case, you will have a hyperparameter for your random class classifier as well, right? So you can correspondingly add grid saying, hey, on your estimator you want to specify, hey, what is the hyperparameter. So you can specify the number of trees you want to grow or the depth to which you want to grow all of these, right? So I will let you look at all of these, play around with that. Okay, so you've gotten a sense of how Spark MLlib is pretty powerful. So you can use all these pipelines and model tuning aspects as well for getting your best model. Thank you.
So in this module, what you have seen is you have played around with Spark MLlib features for pipelining and model tuning, right? So I hope you have gotten a sense of the power of Spark MLlib, and this has given you some more ideas of how you can extend your projects. Thank you. I'll see you in the next module.